live. Okay, so we're doing the same stuff. We're still doing translations or transformations of functions, okay? And it is 9, 12, 19. All right, so in example 2, it's a function, but we don't have an equation. So we can't necessarily do the 2 on the inside of the x, but what we can do is change the graph. So what we have, if the 2 is on the inside, is we have a horizontal stretch. Okay? So if I go slowly, you're going to realize this is actually pretty easy. We're going to take the x values and we're going to stretch them out. That's all we're going to do. Does that make sense? So the easiest one, start at 0, 0, because 0, 0 is right there. So if I take 0, 0, and if I stretch 0, 2 times 0 is still 0, right? So this point here isn't going to move. At the x-axis, its x value is 0. 2 times 0 is still 0, right? But this value here is an x equals 1, right? So if I stretch that out and double it, I get 2. So I'm going to go to 2, and this point right here moves over to there. So this point got stretched horizontally. See how this point here got stretched over horizontally, okay? This x-axis, or x value, is 2, but we're going to stretch it horizontally, so this point's going to go out to 4. So I'm going to take this point and take it to 4, okay? Do you see how the graph's getting wider? It's stretching, right? At 3, this x value here is going to go all the way out to 6, right? So it's going to go off my page, but that's the way it goes. 1, 2, 3, 4, 5, 6, and it's right down there. I'm going to run out of room. This is my x value of 4, but it stretches out to 8. So the graph's going to start to look like, and then I'm going to run out of room to put the rest of the graph. It's really pretty simple, isn't it? Okay, this x value is at -1. I'm going to stretch it out to -2. So this x value stretches out to -2, goes right there. Am I making some sense? Yeah. Maybe? Okay, actually I am. Good. This x value here, right here, the x value is -2, so it's stretched out to -4. So this point is going to go out to 1, 2, 3, 4, right? And then I'm going to run out of room, okay? But technically it's going to look something like that. Okay, does it look twice as wide? Yeah, because I did a horizontal stretch of 2. Okay, pretty simple. Okay, everybody agree? B, 1/2. It's on the inside, so we're going to make it half as wide. So it's going to be a horizontal shrink. From the original, okay, so if we go to the original, okay, at 0, it's at 0, but half of 0 is still 0, right? At 0, half of 0 is still 0, so it's going to stay right there. But at 1, this point right here, x value at 1, is going to be half as wide. So coming all the way out to 1, I'm going to go to 1/2. So this value here comes in, half as wide. This value at 2, x value at 2, is going to be half as wide. So this 2 is going to slide into 1. This value at 3 is down here at -1, but it's going to be half as wide. So at 3, we're going to go to half of 3, and it's 1/2, okay? So this point is going to go to 1/2, which is right about there. This graph, this x-axis, this x value at 4 is going to go half as wide, so it's going to slide into 2. So this point right here is going to move to 2, and I'm going to start getting my graph. Now, I'll do the negatives as well. This x value right here at -1 is going to slide into half as wide, so it's going to go to -1/2. This x value at -2 is going to be half as wide, so it's going to slide into here to -1. This x value at -3 is going to be -1/2, right? -3 is going to be -1/2, which is right there. And at -4, this value here, this x value is -4, it's going to slide into -2, it's going to come all the way into -2, and so I should get something that looks like this. Okay? How's that? It's not that hard, is it? Okay, now, f of -x. So, if the x's are negative, what's going to happen? The x's are over here, and then they become negative, and they're going to flip around and rotate over the y. Does that make sense? We're going to do a reflection over the y-axis, right? Okay. So, we'll go back to the original, because that's the one we're moving. So, at 0, I flip that over, it's going to stay where it's at. Does that make sense? It's going to stay where it's at. Just flip this point right here. It's like the barbecue skewer, right? It's going to stay right where it's at. However, this point at 1 is going to fold or reflect over to here. This value at 2 is going to reflect over here. This value at 3 is going to reflect over here. This value at 4 is going to reflect all the way over here. And this value at 5 is going to reflect all the way over here. So I'm going to get part of it. Looks like this. So I just show the rotation or the reflection over here. Okay. Now we'll reflect the negative x values. Goes to +1.
So we just round it backwards.
Yeah.
I mean, we just started on the opposite side.
Right. Right. So this one here is going to go over here, right? So this point here is going to come over here. So it's going to go right there. This little part's going to go over here and like that. How's that? Right? Now, let's take a look at A, B, and C. And I'll put on my graphics calculator. Desmos is easier to see, but I'm still going to put on my graphics. Okay, so now, to be odd or even, okay? If it is odd, okay? If it's odd, it's going to be a rotation. It's going to be symmetrical. We call it symmetrical to the origin. All right, let me show you an example. There we go. I want this right there. All right, so I don't know if you guys they still sell these fireworks. We used to call them pinwheels. You put a pin right here, and it would spin. Remember those fireworks? You put a pin right here, and it goes zzz. Remember that?
I think they still have
Right.
some.
Yeah. So if this spins 180 degrees from the origin, and if it spins onto itself, so take this 180 degrees. So if I take this, and if it can spin 180 degrees, right? And if it spins onto itself, it's symmetrical. Does that make sense? That makes an odd function. Now, odd functions also have odd exponents, okay? Not all odd exponents will be odd functions, okay? And we can check it by graphing, okay? An even function, okay, put that up here. An even function is going to be symmetrical over the y-axis. Okay, that's even. Okay, your x squared, your y equals x squared. Okay, so if I do my, squeeze it up here, if I do an x squared equation, that is even because it will reflect onto itself. Now, a couple of things. Even functions will have even exponents. Does that make sense? Odd functions will have odd functions, right? We kind of looked at that yesterday. Remember, I put the Desmos on, and we talked about how the odd ones go like this, right? The even ones go like that, right? And that makes sense. And even an x to the fourth was still like this. that would be an even function. But not all of them are even, okay? Even if they're the exponent. So if we graph them, you can see it. So first of all, number one, I'm just going to put this in my calculator. I'm going to graph it. I'm going to go x to the fifth plus an x, all right? These new, darn it, hold on, clear. Try it again. X to the fifth plus x. If I take a look at this one, let's just graph it, okay? Oh, hold on, I gotta fix my window. Window's all messed up. Window, let's go negative 3 to 3, and if I go negative 3 to 3, okay, let's graph this. Okay, there it is. Okay, what do you see? Does it look odd?
Yes.
It does. You can rotate that 100 degrees, and you can turn it, you can spin it, and it spins onto itself. You guys see that? And so this one is definitely odd, okay? When you get to calculus, they're going to show you a way to prove it. We don't need to prove it. We just need to know what it is, okay?
We didn't need to even calculate because it had the number 5.
Well, there are times that doesn't work, but you're right. Sometimes it doesn't work. Sometimes, okay? How about B? Do you think it's even?
Yeah. Even.
Okay, so let's check it out. Okay, let's check it out. If we're not sure, let's just graph it. I get a 1 minus an x to the fourth. Let's just graph it and see what we get, okay?
Oh no. No, that's right.
That looks even because it will reflect onto itself over the y-axis. So that's even, definitely, okay? And then finally, how about C?
Even.
But we're not sure because you got an odd exponent and an even exponent, so it might be neither. But let's graph it. Let's just take a look at it. Okay, if we're not sure, let's do a 2x minus an x squared, and let's see what that looks like. Now, it does not reflect over the y, does it?
But
So it's not.
Not even?
It's not even. Now, here's why it's important, and I'll show you in a second why these are important, okay?
Wait,
If-
you said it's not even.
Oh, not. That's what I meant to write. Not. Thank you. Not. Okay. Here's why it's important.
Odd?
It's neither. It's neither. Okay. Now, if you take calculus, I taught calculus for 20 years before Mr. Massey started teaching it, right? Yeah, it's okay because he's got his master's, so he can give college credit. I never got my master's. It's my fault, but anyway. Show you. But here's why it's important. If you take calculus, okay, you will in calculus be asked to find the area, right? And it's a pretty big problem. If you do it, that's a positive area, that's a negative area. If you do it without even thinking, they cancel each other, you say no area. Does that make sense? This might be an area of, like, we'll say pi, and that might be an area of negative pi because it's down. But they're talking about area. How can you have a zero area? You can't have a zero area, right? Let me stop recording. So in calculus,